Hello, everyone. I think we'll keep waiting a couple more seconds to see if anyone else is joining. So I'll still keep up the music rocking. Good. It's time to start. Hello, everyone. My name is Alexandru Puiu, and I'm CTO of Minded.io. Minded.io is your data and AI transformation partner. We are proud partners of both Databricks and Microsoft for many years now. And together with them, we help leaders in the retail, banking, and more recently, aviation industry to leverage their data, their processes, and truly become AI native organizations. Today with me, I have Vlad Mihalcea.
Hey everyone, my name is Vlad. Thank you so much for joining. I work as a lead data engineer at Minded, specialized in Databricks recently, and together with Alex, I help implement data solutions and consult our business partners.
Thank you, Vlad. And today, as the title says, we'll be talking about how you can optimize your Databricks spending and share with you some tips and tricks for a well-governed deployment in Databricks. During our session, we will talk about a small intro and setting up the context of our discussion, talk about which are out-of-the-box features that Databricks give you to have a proper governance on top of your deployments, but also what you have to build yourself. Because as most of Databricks customers, you will customize your solution to your needs. Then we will also share how things actually look like, not only talk about them, some closing thoughts, and a dedicated Q&A section where you can share anything about um, what you have in mind during the session. As it's in the chat, please leave your questions in the chat or we in the dedicated Q&A section, as we will try to answer all the questions at the end of the session. Good. No further ado. Why is this a governance talk? Because we were gonna talk about costs. Well, you cannot talk about cost and optimization if you don't know how much you consume. And as a consumption platform, you need to know what you consume, who consumes, and where things go. So there are certain aspects, as many consumption-based platforms out there. Usually there you don't have a hard stop, so you can have alerts and understand where your spending is, but there's no one saying like, hey, this is no longer available, you cannot consume over this. Usually the alerts happen with a latency, it doesn't happen real time. And of course, not always the number that you monitor is the number that you pay, because depending on your deployment, you may have some additional costs like storage or VMs for your all-purpose clusters. So these costs add up. You have costs on networking, on your infrastructure. So you have to be aware of everything. And of course, at the end of the day, the better you understand the costs, the better you can optimize. And with those optimizations, the more you can implement. Because, of course, if you get some money back, there's your opportunity to not go ask for the budget and innovate further and bring back value back to the business. Based on our experience, there are several areas where most of the money gets wasted on the road. You have scheduled jobs on all-purpose compute. All-purpose compute is more expensive than jobs compute, for example. And most of the times, these all-purpose compute don't have proper auto-termination. which leads to servers and VMs being spinned up longer than they need to be. You um, lose a lot of money when you switch on Photon everywhere because Photon create increase the DB rate by 2 to 3 times. Um, so that's usually something that you should use when you need it and when you get the most of the performance. If you have a small 10 records dimension, you don't need Photon for that. Um, of course, data lifecycle is or can be a big cost influencer, especially when you work with big volumes of data. We have cases where we've seen storage going to petabyte level, but only like 800 terabytes actual live data. Everything else was versions. So having clean rules about vacuuming and cleaning your data is very important as well. Um, we'll go more into each of these things, but these are the, let's say, top offenders that we've seen in our experience helping our customers optimize their spending and get more budget to deliver more. Usually, when we are talking about the maturity ladder, there are some steps, but I will let Vlad tell you a little bit about them. You're on mute, Vlad.
Sorry, did it again. Thank you, Alex. So everything Alex just showed you gets you to attribution and reporting, basically. Honestly, that part is mostly configuration, what it's already built into Databricks. You turn on the dashboards, query the system tables, you're done. This is the information that Databricks provides you natively, built into the technology. The problem is that that's where it stops. The platform doesn't actually stop anyone from doing the expensive thing, and it doesn't optimize the spending for you. That part you build yourself. Moving forward, I can show you the four pieces of it, what we at Minded do, and advise our customers to do. Let's move forward to the next four. So this is what I'm talking about. The four pieces to it: a governance framework, a persona model, a tagging standard, and a delivery lifecycle. None of them is a feature you actually switch on. Each one is really just a decision written down, plus a pipeline that keeps people honest about it. And that's it. Let me show you what that looks like in the next slides.
But
Okay, let's go to
before
the next one.
that,
Go.
we'll also talk a little bit about what you have out of the box. So, just a quick summary of it. You have the account console within the governance spectrum. So that's your account level view where it was recently released in beta stage, where you have a cost page, you have a tags page where you see your tags, invalid values, gaps, how many of the assets are tagged or not at account level or at workspace level, as well as data NA pages where you can see access, you see data classification, you see quality, token usage, and everything. For that view is let's say reserved for account admins only. As workspace admin, you can see the information for your own workspace in particular. Then you have the uh, policies and timeouts, which is a very important control mechanism that can help you out of the box attribute the costs and limit some of the possibilities that your users can take. For example, the compute policies can allow you to define which are the compute tiers that developers can use within the workspaces. Then you have as well budgets. You can import the pre-built usage dashboard, which we will see in a couple of minutes. And the consumption tab is deprecated. You should use the built-in system tables. as well as in any Unity Catalog workspace. As long as you have the proper access, you have the system catalog with the billing, compute, access schemas that are free to query. They don't hold any cost. Of course, the compute that you use takes some cost. And talking about tagging, it's not as easy as it seems, because there are three, let's say, layers of tagging. You have your custom tags on computes that you can apply to workspaces, to all-purpose, job compute, SQL warehouse, Lakebase, and everything shows up in the system billing tables, and you can enforce them. And there are some limits, like 20 tags per resource, no spaces, but nothing that we've seen to be a limit in real use case scenarios. Then you have the governed tags, which are account level tags, but these apply to data mainly, especially uh, tables or schemas or volumes, and are very useful within ABAC and security policies. And a feature that is now in public preview, serverless policies that allow you to automatically attribute the usage on serverless compute depending on the workloads or depending on the tag framework that you've decided to build in-house. But these are some of the out of the box things. And there are some things that are missing. As I was mentioning earlier, you cannot stop how much compute you spend. You can get notified at the moment. You can review your budgets and consumption, but you don't really get a hard stop. Hey, this is no longer happening. You don't have a clear registry of the tags that matter, and you need to build the way to enforce tagging. Of course, out of the box, there's no cost allocation logic. Even for serverless, you have to create the serverless policies that allocate the consumption to specific workloads. Not a lot of forecasting, because it really depends on how the workloads go. If you have to do a bigger development during one sprint, that will generate a cost that's not necessarily reliable or forecastable for the next iterations. And there's no out-of-the-box operating model. It's your platform. You choose how to do it, and that's why it's very important to think about those things. And we will share some results from customers where we've built platforms from scratch using the right setup, where we've helped customers build their governance, their cost governance model after they've been using the platform for many years, and even to extreme levels with customers that consume over 1 million euros per month. And trust me, the workloads there are crazy. But about how you can build everything custom that I just mentioned, I hand it over to Vlad, who was mentioning about the artifacts.
Yep. Thank you, Alex. So this is exactly what I was mentioning earlier. The four pieces that we can actually control in our frameworks and on the platform itself, because Databricks doesn't really hold your hand on this. You are responsible for implementing all of these governance frameworks and the control layer over everything up on your workspace, basically, from storage to compute. We will look over a governance framework that we designed, a persona model, a tagging standard, and a delivery lifecycle, and a control loop that ties everything together. So as we can see here, there's 5 layers to it. But the thing I would actually pay attention to is the order of these that's laid out here, because when we designed this early on, we realized that the order is more important than what you do exactly. You have to build left to right. If you write a bunch of cluster policies, for example, before you figured out who your personas even are, you just end up with a pile of JSON files that nobody agrees on. So the policies only make sense once you know who they're for. This is why in the operating model, we always talk about the platform center of excellence that owns the policies. Everybody is attributed a role, and they stick to it. So it starts with who decides. This is where the framework begins. Someone owns the policies. As I said, the domains own their spending. Every catalog has an actual name attached to it, and uh, exceptions get an expiry date, because this last bit matters, because every temporary exception we've heard of and we've ever seen without a date on it, it's still there 2 years later. So it's important to track that as well. Then personas, the second one, then the tagging standard, policy library, and Git, and finally the loop that checks it all it's true. And one rule of thumb here that served me well: if a layer doesn't produce something you could actually hand to someone, like a document, a matrix, a Terraform module, then you haven't really built it. You've just had a meeting about it. So it's important to have everything documented, laid out, and it produces an effect. Moving forward, let's go to tagging specifically. Everybody has a tagging standard, more or less. The difference is whether it's actually enforced. And that's this column here, how each tag gets forced into place in the policy. If it's not in the policy, it's a suggestion, and people will ignore a suggestion the first time they're in a hurry or they need to deploy a fix. And two things I find most important about this, actually. First of all, to get it out of the way, some of your spend is never going to have a proper tag on it, no matter what you do. For example, pull-backed clusters lose their tags. Serverless stuff that existed before the policy will have nothing attached to them. So instead of pretending you will get up to 100% cost tracking, you give the leftover an owner and report it as a percentage. Honestly, here's 8% that we cannot attribute yet, beats a number that's quietly lying behind the scenes. But we also track spending that cannot be attributed in the beginning until the platform is mature and the governance framework actually gets a chance to spin up and do its job. Now, second of all, the tagging system with the proper governance, the governance tags cannot touch compute, as Alex said earlier. And the tagging that actually drives your bill has no central repository. So the best thing you can do is use custom tags, which the both of us have used time and time and again. They can be applied on clusters, warehouses, pools, and job compute. They reach the billing system tables that we saw before, and you will see in the demo, and they are enforceable. You can track it, you can control it, and so on. That's it for tagging. Let's move on to these two tools that we use. Terraform for the guardrails and bundles for the workloads. Bundles are declarative automated bundles in the mistake I see constantly, and I've actually made myself, is trying to put everything in bundles. Bundles literally cannot express a cluster policy. The cost objects live in Terraform, actually. So if your guardrails are in Terraform, reviewed like any other piece of code, they're not really guardrails, they're just current settings that you choose on the platform, basically. And here is an important part. None of the checks you actually want exist out of the box. There's not a button you can press that says secure my workload or secure my data flow. There's no linter that fails the build because someone forgot the mandatory tags, nothing that catches an oversized cluster before it deploys, nothing that flags a policy change. Someone changed the policy on the workspace, there's no flag for it that you can review, unfortunately. You write all for yourself. Tag lint, size lint, as you see in the bottom of the screen, a review gate on policy diffs, and a drift check that reads the audit log for the stuff that people changed by hand. For example, running bundle validate, the command checks the schema, not your rules. It doesn't see that, it just sees the code behind it. Those are new, basically. Anyway, let's get out of the slides and we can move into the demo. Alex will show you what's natively built into Databricks, and I will follow up with something custom that we designed.
Thank you so much, Vlad. Let me get everything started. So I hope you can see my screen. As I was sharing with you at the beginning of the session, right now in beta you have a new section that allows you to overview your governance at account level. This is the account console, and if you are an account admin, you may be familiar with this view. But here on the left side, besides the admin controls, you now have this governance section, which tells you very important information about data, how many catalogs you have, how many assets you have, how many governed tags you have, which is the asset usage, how many queries, access grants at data level, at schema level, or at metastore level, as well as data classification or data quality information. You also have recommendation um, regarding unused assets and suggestion for deprecation. You have AI information regarding spending, token usage, governed traffic, and usage. And then you have cost, which is very much important. How much you spent for the last 30 days, month to date, average daily spent. The general critical information, and you can see it by product. You can see how much of the spending was tagged and how much was not. And talking about tags, how your tags look like, which are your governed tags, how many assets you have per your governed tags, how many recent tag assignments you had, data classifications, domains, and recommendations. This is the new area of governance that you have out of the box. Beforehand, you had usage, the usage section, which has budgets, where you set budgets at workspace level, resource types, tags, and understand how much you consume versus how much you budget. And then you had the usage dashboard, which is a pre-built usage dashboard that you can import into your workspace. That dashboard looks something like this, where you have filters for time window, workspaces, and many useful information and very good guideline on how to consume this data, um, showing how much you consume per product type, how much you consume per day. Here, I'm actually looking only at today, and some forecast usage, but not 100% relevant if unless you have like very well-governed solution. Um, and here you have usage overview, usage analysis on tag matching or top objects as well. So, okay, this didn't cache earlier. Um, then what I was also talking about in the beginning, the out-of-the-box controls that you have at workspace level give you the option to build serverless usage policies. By doing this, you can automatically uh, attribute the cost of the compute to a certain use case. So you know that for demo, you spent, I don't know, $20 during the demo session, or for a specific domain, or for a specific use case, you spent um, a specific amount of money. And what gets tracked is known, and you can do something about it. You can show how much the users or the business consumes the platform that you've built, which is the value, and calculate things like ROI. As well, here you can build the serverless interactive execution timeout. And here, this is important because if you have a query that stays there for long times, and sometimes, I don't know, it was a wrong while generated that stays in a loop open, that takes money. So maybe you want to choose, depending on the environment, hey, maybe in dev environment, let's not have execution that takes more than, I don't know, 10 minutes. By default, this number is set up at 2.5 hours, so 9,000 seconds. So have a look over there. As well, you have the compute policies that allow you to define what job computes or what personal computes users can use, from runtime engine, from number of workers to auto termination minutes, for example. These are all things that help you control and define how you generate consumption and how you monitor it. And now to you, Vlad, to
Thank you,
also
Alex.
show what you can build.
Okay, before that, what I'm about to show you is a dashboard that we designed and we offer to our customers based on the overall feedback that we had from our earlier project. What people actually want to look at, what's useful information, and all of that good stuff. It's good. Let me know if you can see the screen.
Yes, we can.
Okay. Awesome. So what we're looking at is an operational usage monitoring dashboard. This queries specifically the system tables, where all the data accumulates based on your spending. It tracks all the compute usage and the storage. Also the user footprint on your workspace. Main page is an overview, provides you with the total costs based on date filters, users, and workspaces. Distinct SKUs, the computes that you have running on your workspace. Daily cost trend, as you can see, the spike here is we generated usage for this demo using the demo tag that Alex mentioned before. Which of the products generates the most cost? In our example, is SQL, and mainly will be SQL in a data-oriented workspace. Which of the SKUs produce most of this consumption and usage? The users, you see this user consumed about $30 of DBUs worth mainly from SQL. Moving forward, we have a cluster compute analytics, which follows only the cluster computes, job clusters mainly. Anything that's created, how much it runs, what's the usage per hour or per week. This is how you track your automated jobs. Which project consumes the most. This is a heat map, so you can decide on whether you need to, I don't know, space out your automated jobs. You can see a pain point, maybe at 5 a.m. in the morning, everything runs at the same time and you hit some threshold in your cloud provider's VM creation rules. Users per compute. Going into more details is the SKU details tab, which goes into usage type, cost per SKU. What are your top computes that have been used? And the users, again, that are using those computes. Here, cost by compute type, this is one of the most important ones because it provides an overview of what features are most popular and ready for cost optimization, so to speak. So serverless SQL, of course, it will be mainly the first one, but you'll see Lakebase, Genie, depending on how you're using your workspace. Further down will be detailed tables that you can export and do further analysis on. This shows exactly where the data is coming from. For data usage, this tracks the tables and the data that you present in the workspace. What are your most queried tables? In our demo will be the system tables as we are using this dashboard, but in a real life scenario, you will see mostly gold tables that are used for reporting most likely. How many queries per warehouse? As you see, we have a dashboard that's consuming most of the queries. This dashboard in question. Query activity, how much data is being read in gigabytes from each table, so you can spot oddities and stuff like that. SQL warehouse cost per user. This you can track either by user or service principal, which team or which department, for example, derives the most cost out of using SQL warehouses for queries or for interactive analysis. Warehouse cost and query volume per by source and compute type. So here, most of the queries come from this dashboard and some from serverless compute used inside the notebook. This is the interactive analysis I was talking about.
A good
Does
note
it
here.
go ahead?
This is, let's say, the plain information. Usually, some of those views also have in consideration the tagging, but because tagging is personal, it's depending on how you build your operating model. You don't see it here, but this is one of our recommendations. Always look also at usage and consumption generated by tags and try to um, uh, combine and cluster your workloads on using tags. You do it by domains, by project, up to you. But this is a very powerful tool.
Yep, exactly. And we also include something like this when we have a collaboration. It's either a different dashboard that is specifically tracking the tagging, or we include it in this one. It depends on the situation. The page I'm looking at is access and lineage. This shows you how many tables in your workspace are over permissioned, tables that everybody in the workspace has access to. This should be zero. There shouldn't be any one table that everybody has access to. Privilege changes, you can see I've received use schema and select permissions on this workspace and these system tables, so I can use this for my demo. What are the top tables that are being used on the workspace? Moving over to the last one, which people find really helpful, is the user consumption, which basically targets cost optimization and transparency over how the users actually engage with your workspace, with your compute resources, the DBUs and costs they generate. As you can see here, total events. These can be queries, these can be jobs, anything that's using a compute resource to operate the workspace. Cost trends over a week. The activity by category Unity Catalog, that means a lot of queries were done on Unity Catalog managed delta tables. Cost by product, what's the most popular product your users are engaging with. And these are user cost by query source and compute type. It's the same as two previous pages ago, but it's focused on user. So this is the dashboard. This is, of course, customizable, and we enhance it with whatever a customer needs. And for more technical people, this is all based on the system tables provided by Databricks. So all this information is native and can be found in Databricks. It's just a matter of how you use them, interpret them, and show them, basically.
Almost, because you also have
Yeah.
to build in some of your custom data, like the tags and everything. But thank you so much, Vlad, for
Yep.
this. Because we are getting closer to the end of our webinar today. Here, let's go quickly to three things that you should get out of this webinar with.
Yeah. So let me take the first two because they're fresh. Well, if there's one thing from my half of the presentation, cost is a lagging indicator. It's the result of all the actions and resources on your workspace. Every actual saving I've been part of, or we've been part of actually, came from a decision further upstream. Who could spin up compute? What is the policy led through? Whose name was on the catalog? If you go straight at the bill, you will get these blunt cuts that come right back. You cannot just cut a cost if you don't know where it comes from. Go at the decision and the bill just follows. It all starts with attribution. And as I said, because you cannot cut cost if you don't know where it's coming from. The second one is what makes it actually stick. Separate dev from prod at the catalog workspace level, of course, not just we're being careful and we can operate like this. You need to enforce it. Policies in Git, workloads in bundles, as we talked about, the service principle owning production. So no person needs right access to production data. Because the honest truth is any rule that isn't enforced by a pipeline falls over on the first deadline. Someone always has a good reason to skip it just this once. A guardrail sitting in a repo survives this.
And
So
you
yeah,
and
that's it.
you can
That's good.
enforce it because that's where CI/CD and automation
Yep,
processes comes in handy. With
exactly.
CI/CD, that's the only way you can work it. You don't have the permissions to do it manually. And this is back on governing by design. Yes, it's always easier to say, hey, why haven't you thought about this when you start fresh, when you start now? But many of our customers are early adopters. They have been using Databricks for 3, 4, or 5 years or even more, and some of those capabilities were not there uh, that much time ago. But that doesn't mean you should not always think with governance in mind. You have to build a new domain within your data mesh architecture. You have to decide and bring new capabilities for a machine learning project. If you haven't done that, that's the best moment you can look and say, hey, let's start with this. So I'm doing something for the data scientist. I'm identifying the persona, I'm setting up the tags, I'm setting up the policies, and I'm running this for this new use case. You already set up the ground. That gives you the momentum to go back, fix what was there before, and set the bar moving on. At the end, if you don't need to create something and it's just a matter of a moment, maybe it's easier to manage. But moving on. Some of our success stories, as I was mentioning in the beginning, when you build from scratch, it's easy because, especially on our side, we bring over 5 years on building on Databricks and over 10 years on building enterprise grade data platforms. So we've seen it almost all. We've seen those complex scenarios near real-time situation, batching, streaming. It's easy when you've seen many things to decide which is an overload and which is the best practice. That's how we can build platforms that cost less than 500 euros per month for all the environments, not for production only. And you cannot really do so much better than this, if I if I if I may say so. And we had a webinar exactly on how we built that. But even if you are one of the early adopters, there's no better time to start than today. Okay, maybe tomorrow. And here we have success stories of saving over 40% month on month just after 1 month of working together with our customers, identifying the root causes, defining which is the best plan to action, and implementing it. So these kinds of processes allow them to move faster with some of the workloads because suddenly they didn't really have to ask for extra budget to allocate to agent bricks and to increase their spending on Databricks because they found it and it was always there. And of course, when we are talking about complexity and scale, not everything has to go down to every project. That's why we always think thoroughly before giving a recommendation what's worth it. You may not want to really have um, all-purpose clusters that automatically turn on and turn off when the processing starts. But when you have 2000 processes that start and consume that cluster, you want to be optimal. Going for for serverless style compute may increase those costs, or it may increase the processing times. You can very well control this, but this makes sense when you have a real impact. Otherwise, spending days or weeks to build a custom mechanism doesn't really make sense. And for you to take it action in practice today or Monday, you can take a screenshot of this. You'll also find this on YouTube, and you can also get this quiz from our colleagues if you participated today. you have five areas that you should look at. And depending on how many of those you do, you can just do simple math over there and divide the scores by the number of areas. If you are doing it, then it's full score. If you are partially doing it, then it's half score. You can calculate this for yourself. Or if you need help, we are here. You can contact us at contact@mindy.io and we can build together a session on how we can help you really go in depth in your deployments and understand what you can do more and deliver more with the platform that you already have. Um, and that would be it. We have some questions because we're a little bit over time. Uh, so, uh,
I think we can take one, maybe two questions
do you want to take any
real
of
quick.
them, Vlad?
Yeah, I see someone is asking that our dashboard sometimes doesn't match the invoice, and why does that
Mm-hmm.
happen? That's a that's actually a good question that we get quite often. Uh, the the main reason is that the prices laid out by Databricks in the system tables are list prices. If someone has a discount or a preferential price on the workspace on a certain compute resource or anything like that, the bill will be different. So that's the
Mm-hmm.
main reason. They are list prices that can be found on Databricks' website based on your cloud provider. It's a standard for everybody. But if you have a specific discount or, I don't know, negotiated a better price for that, that's why it will not match the exact bill. But you can get an overview over it.
As well, you may have some resources that are not part of your database consumption. For example, you can have networking on geo redundancy, you can have storage, you can have VMs for your all-purpose clusters that don't show up easily
Yeah.
in Databricks. In Databricks, unless you actually ingest that data, in Databricks you will see your DBU spending. That's what's tracked under the billing schemas and the internal billing system of Databricks. And we'll just take one more. Whether is serverless cheaper than classic? Uh, the
It depends.
the favorite answer, it depends exactly. Um, if you can control very well the um, workload that you have and you know, hey, I have a processing window, 2 hours, starts at 12 a.m., runs until the last process around 2 a.m., and then I have no need for job compute and everything, and I have enough jobs. Um, then yes, Classic can be a very powerful tool. And it's not hard to manage. Um, but if you have sporadic interactions, if you, for example, a development environment, you can get more from serverless than you get from all-purpose compute because you are not always writing queries. You are sometimes spending time in meetings. You are sometimes um, looking at the data, exporting the data into Excel or to Power BI or some sort of data analysis tool, and you don't really need compute running for 30 minutes or 1 hour when you don't attack that consumption. So.
Yeah. So on top of that, just to add it, in our previous experience on big data platforms, it's always a mix. Depending on the project and workload, you can go with serverless over job computes, for example, if you need some automated jobs to be snappy. Whenever you need them, you run them. But it's also a mix. You cannot choose a path and go with it because your cost will vary too much and it's hard to track. So variety is the spark of life as well as in Databricks.
Yeah. And the last one, whether there's a way to track storage cost without importing cloud provider's data or tagging tables and it sends it to the cloud provider. So storage is usually part of the cloud provider of your choice. And that comes with some particularities. You may have redundancy, you may not have redundancy, which adds. doubling your storage, or actually it's increasing the pure storage cost. The redundancy and the overhead happens behind. Or you can have, for example, network. If you do over continent redundancy, then you have bandwidth cost, networking cost between Europe and US, for example. So that data is not managed in any way by Databricks, although you may have managed storage accounts and everything like that. It's managed by the cloud provider itself. Moreover, newer capabilities like cross-cloud disaster recovery and high availability make it harder to track because you may have different deployments. Right now, to my knowledge, the easiest way is to import the consumption into Databricks. And tagging should also seen in the billings, but I need to double check this for if it also works for storage with the tables. For sure, you can see which are the storage accounts or S3 buckets that you have attached to your database deployment. And I hope with that we answered the questions. Thank you very much for attending today. Hopefully it was an insightful session. If you have any other questions, feel free to reach out to us, and wish you all a great week ahead.
See you, everybody. Thank you for joining. Bye-bye.
Take care.